Hello, everybody. What I want to do today is I want to talk about the next section, which is dealing with intercepts, extrema, and intervals of a function. So let's first talk about the intercepts. There are two types of intercepts. There's what's called the x and y intercepts. And what are the x and y intercepts? Well, those are where the curve crosses the the x or y axis. Essentially, when you talk about x-intercepts, um, this happens where y is equal to 0, and the y-intercepts, or actually the y-intercept, is when x is equal to 0. That's that's where they happen. So if you were to draw a if we were to have a curve, like if I have something like this right here, and this right here, those are my x-intercepts. And so this is going to be where y is equal to 0 because this is along the y equals 0 line. That's a horizontal line. And then my x-intercept is going to be right here. And this is actually the x equals 0 line if it's a vertical line. Do you remember that? Right? So here's the crazy thing that you need to be aware of. The crazy thing about this is that a function can have, so a function a function can have 0 or 1 or 2 or many x-intercepts. Okay, and that just depends on several things. However, it can have, and this is important, at most one y-intercept. So that's important. All right. So ideally, you want to think some other things that they talk about is that when they say when they talk about zeros of a function is the same as x intercepts because the value is 0 when you do that. So a nice little thing about that is, you can look at curves and whatnot, and it will show you the 0. Okay, so looking at this guy right here, you can see that this right here is an x-intercept, that right there is an x-intercept, and this cowboy right here, that's your y-intercept. Here you have an x-intercept, x-intercept, or excuse me, y-intercept right there. So you can see that the y coordinate of your intercepts for the x are 0, and the x coordinate of the y-intercept is always 0. And then you've seen this in the line. So there's your y-intercept and here's your x-intercept. So that kind of makes sense that when you find that the zeros are the points at which the function intersects intersects the x-axis. Now, if you want to find zeros algebraically, if you want to find the set f of x equal to 0, that is, set your function equal to 0, and you solve it for x, that finds your x intercept or your zeros. This finds the zeros. Finds the zeros. Now, for your y intercept or your y-intercept, you actually plug 0 in to the function. And there's to do it algebraically. Okay. The nice thing about it is that you'll have some time to practice, and you'll be able to do this. But like if it's a polynomials, the constant term is always going to be your y-intercept. But again, to find the zeros, you set the function equal to 0 and you solve it algebraically. And to find the y-intercept, you plug 0 in for x. If it's a polynomial, it's just the constant term. It's super easy. Nothing to worry about. Remember that you have multiple x-intercepts, but you can have at most one intercept. And that should be pretty much review. What I want to talk next is something that we call critical points. Now, what the heck is a critical point? What is a critical point? Critical point. So, a critical point, all right, critical points are where graphs change the direction or shape. All right. So, what do we mean by that? The critical points is when they change direction or they change shape. So, some vocab that comes up. There's something they call extrema. Sounds super fancy, but they call it extrema. And extrema is so you've known your extrema. Extrema is where the are there are points where the graph changes direction. All right. So where this comes into play, you have for that you have relative max, relative min. You've seen that probably in algebra 2, and then you have absolute max and absolute min, and you may have not heard about that, but we'll talk a little bit about that. And then there's another thing that we need to know about, and that is the other one that we talk about is called point of inflection, and this will come up. This will come up in calculus. Point of inflection. What is a point of inflection? A point of inflection is where the graph changes its shape, but not direction. That's called a point of inflection. So what does this look like? All right, well, I can show you what it looks like a little bit with the goofy graph. If I take a graph and I'm just going to sketch it, and it's just some goofy, I'm going to make it a goofy polynomial. Okay, there's a couple key components here. This spot right here, this spot right here, and this spot right here. Okay, this spot right here, I would say that that is a maximum point. That is a maximum point. Now, really, this would be called a relative maximum point because these arrows mean they go on forever, right? That's a relative maximum point, all right? This guy right here, this right here, this is a point of inflection. That's a point of inflection. Why is that a point of inflection? Because it is actually changing the shape. It's going in a different shape, but it's still decreasing if you look at that. And then this third spot right here, this guy is what we call a minimum value. And in this case, this would be your min. And it would be known as a relative minimum point because this arrow means it goes down, it goes on forever. Now, what does, like something more like what does an absolute min or an absolute max look like? Well, I'm glad you asked that question. This guy right here and this guy right here, two of them. This one is a relative max because it's kind of the highest point around some stuff. But this one right here, that one right there is that's an absolute. That's an absolute maximum point. There's no doubt that um, that's going to be the highest point that this function is ever going to get. The easiest way to do this is to put it in the calculator, put it in the decimals, and click on the spots to get the actual points. But you'll have time to do that on your own, or maybe we'll do it in class. Who knows? Okay. The next thing I want to talk about is when they talk about increasing and decreasing behavior or intervals, right? So, so what is that? What is increasing and decreasing intervals? So basically, and well, increasing and decreasing behavior. You talked about end behavior, but increasing and decreasing behavior. All right. So increasing. So what does this mean? What's the definition of that? So how I describe this is if um, you're moving well, you're moving left to right, moving left to right. When you go from left to right on the graph, a function may increase or decrease or remain constant. If that makes sense. So it may increase or decrease, or it may remain constant. So what do I mean by this? So let's look at like a graph. So I'm just going to draw something up here real quick, totally off the cuff. I'm going to go like 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 2, 3, 4, 5, 1, 2, 3, 4, 5. And now when I do this, I'm going to go um, so here's a function, okay? And um, there's a couple parts here where you look at, like if I'm going to put, I guess I'm going to put a dot right here. I'm going to put a dot right here. Now, when you talk about the behavior of a function, as we come from left to right, you can see this part right here is going up. Can you see this part? It's going up. This is like increasing. And it gets this spot when it looks like its x is at -2. I'm increasing. So really, I would say from negative infinity to -2 is increasing. Why? Because I'm going up. But then from -2 to looks like 1, 2, 3, 4. From -2 to 4, I'm constant. But I can't include that because I don't know what's going on there. But from -2 to 4, I'm constant, which is fine. Think of it as slope of 0. And then what's happening here? From net 4 forever is decreasing. So from 4 to positive infinity, you are decreasing. And that's how you talk about when they talk about interval. All right. Functions act all goofy and crazy, and you'll have some time to practice that. But that's pretty much what you need to know about functions and their graphs: the intercepts, the zeros, the extrema, the increasing, the decreasing. Now all you really need to do is just practice it. So I'll see you in class real soon, and may the force be with you.